before we discuss any formula, let's discuss Pythagoras theorem. You must be thinking why. So hold on for a question. Let's discuss. Then we are going to relate with the coordinate geometry. So let's start with the Pythagoras theorem. We know Pythagoras theorem is valid for right triangle. Okay, so it is a right triangle. It has a 90-degree angle and it has base, then height and hypotenuse. Done. Very simple. We are only talking about the most basic knowledge. So what is the Pythagoras theorem? It says that hypotenuse square is equal to base square plus height square. We have learned this in triangles chapter as well. Very simple. Now if you want to find the value of hypotenuse, what will you do? You will do square root. Why? Because it is square over here. So if I want to remove square, I need to take square root. Simple. I am going to assume few values of base and height. Then I am going to get the value of the hypotenuse. Let's do it. I am going to take base is equal to 3 centimeter and height is equal to 4 centimeter. So many times you have done this question that base is 3 centimeter, height is 4 centimeter, and you also know the answer of it, which is 5 centimeter, right? So let's get the answer. What I'm going to do, I'm going to substitute the values. So base square, what is the value of base? Which is 3 square. Then what is the value of height? Which is 4 square. Then it is under the square root. So let's write this square root here, which is square root. Remember? Done. Now let's move for the next step. So square of 3, which is 9, plus square of 4, which is 16. Now 9 and 16 will add it, and what will be the answer? Can you guess the answer? Yes, it is 25. Answer is 25. And if we take this square root of 25, what are we going to get? Simple answer, which is 5. And I will be writing unit as centimeter because base and height unit is centimeter. Simple. We know this. I told you that you already know the answer and we have done so many times. So this is the basic idea. Now, very simple concept we know, but this concept I am going to relate with coordinate geometry. That is the most important concept you need to learn. Okay, so I have taken 2 points, which is A1, 1. Okay, I have plotted over here. See, you start from the 1, x-axis 1, y-axis also 1. So 1 from here and 1 from here. Where do they meet? At this point. I've already labeled it A and A1, 1. Then let's do for the B. How would you plot the point B? So B is 4, 5. 4 from here and 5 from here. They are going to meet at B. So A and B. Now I want to find the distance between A and B. And you know in mathematics, shortest distance between any 2 points is always straight line. Shortest distance between any 2 points is straight line. So that is the reason I am relating this coordinate geometry along with the Pythagoras theorem. So how shall we do it? Can you think of a way that how can we find this distance? I know we have only 2 information, A1, 1 and B4, 5. We don't have any other information. So let's think, how shall we do it? First of all, I am going to get one arbitrary point, constant, right? How shall I get it? That plays very important role. I am going to use Pythagoras theorem to find this distance. Okay, now relate one thing. Hypotenuse is slanted and so do AB. So if I can make a right triangle over here in coordinate system, if I can make right triangle over here, what I need to do? I only need to use this formula. Simple. Base square plus height square. Simplify it and get the answer. So this is the reason we discuss Pythagoras theorem. I am going to make a right triangle over here. Correct? Then I will be using this formula. Then I will be getting the value of AB. For that we need to have base and we need to have height. Simple. I hope you understood. Let's make the right triangle. So what will I do for that as well? I will extend this point. I will draw one dotted line over here and from B as well. And wherever they are going to intersect, that will be this point where it will be 90 degree. Let's do it. Okay, then I'm going to draw one more line from the B as well, and it will intersect somewhere. Right, this is the point I'm interested in. So let's highlight the point. I'm going to name that point C. Now, what information do I need for C? Can you tell me the coordinates of point C? See, you can see over here that x-axis, what is the x-axis? 4. So x-axis 4 and y-axis 1. Very simple. So coordinate of point C is 4, 1. Now, let's use this simple logic now. If you want to find AC, if you want to find the AC, how can I get the AC? Think, I want base. I want to find base. Let me label over here so you'll get better idea and compare with Pythagoras theorem. So this is base. I want to find base, this line. How can I get the value of this line, which is AC? Can I label over here that AC is equal to base? Very simple. A starts from here and C stops at here. So between this line, see the x-axis points, it is 4 and 1. So if you subtract them, 4 minus 1, that is the value of base, which is 3. So let's write over here, base, which is 4 minus 1 is equal to 3. Done. Let's do same for the height. Same for the height. Okay, so what will be the value of height? Here I have subtracted the x coordinate, but in the height I am going to subtract which coordinates? Yes, y coordinate. See, 1 over here and 5 over here. So 1 and 5, I need to subtract them. 5 minus 1 will be what? 4. So let's write over here. And what's the name of the height? Name of the height is BC. So BC is equal to height. BC is equal to height. And what was the value that we calculated? 5 minus 1. 5 minus 1 is equal to 4. Clear? So I have base, I have height. Now, can I get the value of hypotenuse? This is the value of hypotenuse if we find it. And that same hypotenuse value is also the distance between point AB, right? So when I find the value of hypotenuse, what I'm going to get? I am going to get distance between point A and B. This is the reason that we discuss Pythagoras theorem, and this is how we are relating these two concepts, coordinate geometry and Pythagoras theorem. Let's do it. So if I want to find the hypotenuse, I will be using the same formula, base square plus height square. Let's write. Hypotenuse is equal to square root of base. What is my base over here? AC square plus what is my height? BC and square. So AC, which is 3 square, BC, which is 4 square. So again you are going to get the same answer, which is 9 plus 16 and square root of 25, and that is 5 units. You can write units. Here also we can write 4 units, and here as well 3 units. Okay, we got the value. Now you must be thinking that every time we are going to draw this. No, we are not going to draw every time this one. So we are going to generalize this concept. Let's do it. So what did we do first of all? See, AC is equal to base 4 minus 1. Now let's write those points again. Important. A and 1 comma 1, and I am going to take A as x1 comma y1 and B, which is 4 comma 5, I will be taking B x2 comma y2. I want to make formula. So if you want to find the base, you subtracted 4 minus 1. What is 4? Which is x2. Then what is 1? Which is x1. So basically, what have I done to find the value? I have done as x2 minus x1. Then what I need to do of it? Square. So I have done x2 minus x1. Subtraction is done. After subtraction, we have taken square of it. So square, then plus. For height, 5, which is y2, and 1 is y1. So y2 minus y1. Height is done. To find the hypotenuse, we need to take square. Then if you want to find the hypotenuse, you need to take square root as well. And I told you that hypotenuse is distance between A and B. So I can write here as distance. This is the formula of distance. Distance is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. If you want to write in a different way, you can also write like this. You can change the order of those coordinates. Y can be changed. Here I can also write x1 minus x2 whole square plus y1 minus y2 whole square. That is also correct. Can you tell me why? Because it is square over here. Square is always positive. Either you subtract 2 minus 1 or 3 minus 1. You are going to get the answer as 2 or minus 2. And if you do square of it, answer will be always positive. That is 4. So let's recall what did we learn in this session. We learn about the coordinate geometry. Then we learn Pythagoras theorem. And the most important concept, we combine the concept of coordinate system and Pythagoras theorem. So what have I taken? I have 2 points. Then I made the right triangle. With the Pythagoras theorem, I have found the distance between A and B. Remember, this distance is hypotenuse of the right triangle. So with the help of Pythagoras theorem, I have derived the general formula that how to find the distance between any 2 points. So I don't need to keep drawing this line in every question. If I use this formula, though, I can get the correct answer. So this was the topic of finding distance with the help of formula. Let's discuss few questions based on the distance formula we learned in previous session. Find the distance between the points 2, 3 and 4, 1. And one more question we will do afterwards. Let's start. So first of all, you need to do is name the points. Name the points. I am taking A as 2, 3 and B as 4, 1. And if I want the distance between point A and B, I will be writing as AB, capital AB. Remember, whenever you name the point, always take capital. It's a rule of geometry. Now, if I want to find the distance, I need to use the formula. So remember this formula, which is x1 minus x2 whole square plus y1 minus y2 whole square. You must be thinking, what is x1 and what is x2, y1 and y2. So we will be taking first point as A and second point as B. So let's do it. Rather than thinking of the x1 and x2, always remember AB means you need to take the point from x-axis, x coordinate from the A and x coordinate from the B and subtract. So that will be 2 minus 4 whole square plus 3 minus 1 whole square. 3 minus 1 whole square. Then here 2 minus 4, that is minus 2 whole square plus 3 minus 1, that's also 2 whole square. And if I write in a normal form, minus 2 square, 4 and 2 square, that is also 4. So here 4 plus 4, 8. Now you need to simplify it. Always remember, whenever you get any kind of composite number like that, first of all think of the factors of that number. What are the factors of 8? 1 8s, 2 4s, 4 2s. Both are same, 2 4s and 4 2s. So what you need to do, always try to write factors of that number in terms of perfect number. Okay, so there are two factors. This is perfect square, 2 is not. So how I will be expressing? I will be expressing as 4 multiplied by 2. Now I know square root of 4, which is 2. So I will be taking out. So 2. We don't know the square root of 2, right? So we are going to keep as it is only. We are not going to simplify it. We'll keep 2 as it is because we cannot find the square root of 2. In terms of whole numbers, we can find the square root of 2, but not in terms of whole numbers. So this is my answer. And here you need to write the units. Unit means either it can be centimeter, meter, kilometer, whatever. We don't know. So we write for the purpose of understanding that there must be one unit. So you need to get 2 points, then apply the formula, simplify. If you can take square root, then take it. Otherwise, simplify in the normal form. Let's do another question. Here AB and minus A and minus B is given. So I am going to take in this case X and Y. X as A comma B and Y as minus A comma minus B. Let's solve this one. So if I want the distance XY, in this case it will be XY. So again write the formula, which is x1 minus x2 whole square plus y1 minus y2 whole square. So x1, what's the value of x1? Okay, you will be taking x coordinate of x, which is A. So A, then x coordinate of y minus A. Be careful, minus sign for the formula and minus A because it is given in the point in coordinate. So square plus then y1 b over here minus b again. Remember that, be careful. So square root again here. So a minus plus a whole square plus b minus plus b whole square. Done. Now let's simplify further, which is a plus a, that will make 2a whole square, b plus b 2b whole square. Then let's take squares. Square of 2, which is 4, square of a square, square of 2 4, square of b, which is b square. Now 4a square plus 4b square. Can I take something common? Yes, I can take something common, which is number. So 4 common here, then a square plus b square. Now we know that 4 is a perfect square, and if we take that number out of the square root, what will be the answer? 2. We have done just now. So my final answer is 2 over here, and in square root it is a square plus b square. So this is how we find the distance between 2 points when numerical value is given and whenever any variables are given. So this is how you find the distance between 2 points. Let's discuss one interesting question. This question is asked many times for 1 mark. It is very easy as well. It asks for the understanding. Let's read the question first. Find the distance of 5, 2 from the origin. Okay, we need to find the distance. First condition, we need to find the distance. It's written there, find the distance. And distance of 0.52 from the origin. So one point is given, but another point is not given. You must be thinking, how can we find the distance? To find the distance, we need 2 points. One is already given and another is missing. But see, it is given origin. Origin, it is given. Origin means what? What are the coordinates of origin? Starting point of the coordinate system, 0, 0. So second point is also given, but indirectly. Remember, this is very easy. Let's start. I am naming this point as A, which is 5, 2, and this origin as O, which is 0, 0. Done. My 2 points are there. Apply the formula and get the answer. This is very simple. You know what is the formula, distance formula, and get the answer. So I want to find the distance, which is AO. So again, square root. Let's write the formula. x1 minus x2 whole square plus y1 minus y2 whole square. Simple. Now let's get the values. x1 minus x2, x coordinate of A minus x coordinate of O, which is 5 minus 0. So 5 minus 0 and whole square. Don't forget to write the square over here. You'll get the incorrect answer otherwise. y1 minus y2. We'll do same. Y coordinate of A minus y coordinate of O, which is 2 minus 0 whole square. So let's simplify. Here 5 minus 0, which is what? 5 square only. So 5 square, and 2 minus 0, which is 2 square. Let's write the squares now. 5 square, which is 25, plus 2 square, which is 4. Do not even by mistake write that 5 2s are 10 over here. I've seen many mistakes like that. Don't do it. 5 square. You need to think as 5 multiplied by 5, not 5 2s are 10. So if we add, you are going to get 29 units. Now, can we simplify this square root of 29 further? No, we cannot, because 29 is prime number. And you know factors of 29 is only 1 into 29, right? So this is important question. It is direct, indirectly it is given. One point is there and another point information we need to get from the logic. Origin O00. Then get the distance and your answer is square root of 29.